Welcome back to the Real Number System. In this video, we'll be covering section 4.1 on divisibility. So we'll talk about what the word divisible means, we'll talk about what factors and multiples are, and we'll look at divisibility test. So let's get started. An integer is even if it has a remainder of 0 when the number is divided by 2. Otherwise, the number is odd. Now we say for whole numbers that b divides a if and only if there's a unique whole number that we can multiply times b and get a. And you see the notation that we use for b divides a. If b divides a, then we call b a factor or a divisor of a. And we call a multiple of b. For instance, we say that 3 divides 18 because the remainder is 0 when 18 is divided by 3. On the other hand, we say that 3 does not divide 25 because the remainder is not 0 when 25 is divided by 3. Now there are several different ways for stating the fact that 2 goes evenly into 12. We might say that 12 is divisible by 2. Or we might say that 2 is a divisor of 12. 12 is a multiple of 2. 2 is a factor of 12. And 2 divides 12. So let's look at some statements, and we're going to classify whether or not each of these statements are true or false. Part A, 3 divides 12. Now that vertical line between 3 and 12 means divides. So 3 divides 12, well this is true because 3 times 4 is 12. Part B, 0 divides 2. Now this is false. It's false because there's not a whole number that I can multiply times 0 and get 2. In other words, we say there's not a whole number n such that 0 times n equals 2. Part C, 0 is even. Now remember, our definition of even is that there's a remainder of 0 when we divide the number by 2. So 0 is even because 0 divided by 2 is 0 and there is a remainder of 0. Part D, 8 does not divide 2. That is true because there's no whole number that I can multiply times 8 and get 2. In other words, there's no whole number n such that 8 times n equals 2. Part E, for all whole numbers a, 1 divides a. Well, this is true because 1 times a equals a for every whole number. Part F, a squared divides a to the 5th. Well, this is true because a squared times a to the 3rd equals a to the 5th for every non-zero whole number a. Part G, 3 divides 6n. Well, is there something I can multiply times 3 to get 6n? Yes. So this is true because 3 times 2n equals 6n for every integer n. And then part H, 0 divides 0. Well, at first glance, you might think this is true. Is there a whole number that I can multiply times 0 to get 0? Well, yes, there is. But the problem is that whole number is not unique. And part of the definition of divides is that that whole number has to be unique. So this one is false because there is not a unique whole number such that 0 times n equals 0. Let's look at some properties of division. If d divides a and n is a whole number, then d divides n times a. In other words, if d is a factor of a, then d is also a factor of any multiple of a. Part A, another property of division. If d divides a and d divides b, then d divides the sum of a and b. However, if d does not divide a or d does not divide b, then d does not divide the sum. So if D divides A and D divides B and A is greater than or equal to B, then D divides that difference of A and B. Now once again, if D doesn't divide A or D does not divide B, then D is not going to divide that difference. So let's look at some more statements, and we're going to classify these statements as true or false. Part A, 3 divides X and 3 divides Y. Does 3 divide X times Y? Yes, this is true, because if 3 is a factor of X, then 3 is a factor of any multiple of X, and X times Y is a multiple of X. Part B, if 3 divides X plus Y, then 3 divides X and 3 divides Y. Well, this is false. Let's suppose we have 15. Well, 3 divides 15. I can write 15 as 11 plus 4. But 3 doesn't divide 11, and 3 doesn't divide 4. Part C. If 9 does not divide A, then 3 does not divide A. This one is also false, and I give what's called a counter example. So again, let's think about 15. Well, 9 does not divide 15, but 3 does, and so this shows that that statement is false. The next topic that we're going to cover in this section is divisibility test. So let's start with divisibility test for 5 and 10. So a whole number is divisible by 5 if and only if the units digit is divisible by 5. So that means we need to have a 0 or 5 for our last digit. Now, if a whole number is divisible by 10, its units digit is divisible by 10. In other words, the last digit is going to be 0. So we want to know if each of the following numbers is divisible by 5 and by 10. So our number here in part A is 56,205. Well, this end ends in 5, and so yes, this number is divisible by 5. Now this number does not end in 0, so the number is not divisible by 10. On your quiz in the show workbox, you'll have to give a reason for your answer. You will be expected to show a statement something similar to what I've shown in the video. Let's look at 7,820. First, I want to decide if this number is divisible by 5. Well, the answer is yes, because the number ends in 0. Then I think about 10. I look at that units digit, the last digit. Is it a 0? Yes, and so this number is divisible by 10 because it ends in 0. Part C, 678,021. This number is not divisible by 5 because it does not end in 5 or 0. This number is also not divisible by 10 because the number does not end in 0. The next test that we're going to look at is a test for 2, then we'll look at a test for 4, and a test for 8. So a whole number is divisible by 2 if and only if its units digit is divisible by 2. In other words, is the number even? Now, a number is divisible by 4 if and only if the last 2 digits are divisible by 4. And a number is divisible by 8 if and only if the last 3 digits are divisible by 8. So let's look at some examples. We want to know if each of the following numbers are divisible by 2, 4, and 8. So in part A, we have 97,128. Well, yes, this number is divisible by 2 because the number is even. For 4, I look at the last 2 digits. The last 2 digits are 28. Does 4 divide 28? Yes, and so 4 divides our number because 4 divides the last 2 digits. With 8, we look at the last 3 digits. So I'm going to come down below and I'm going to divide 8 into 28. Notice that there is no remainder. And so here, 8 divides our number because 8 divides the last 3 digits. So for 2, we look at the last digit, for 4, the last 2, and for 8, the last 3. Our next number is 83,026. Does 2 divide our number? Yes, the number is even. What about 4? Well, for 4, I look at the last 2 digits. My last 2 digits are 26. 4 does not divide the last 2 digits, and so 4 does not divide our number. For 8, I look at the last 3 digits. The last 3 digits are 0, 2, 6, or 26. 8 does not divide 26, the last 3 digits, and so 8 does not divide our number. In part C, we have 127,204. Our number is even, so 2 divides our number. For 4, we check the last 2 digits, which are 0, 4. Does 4 divide 4? Yes, and so 4 divides our number because 4 divides the last 2 digits. For 8, we check the last 3 digits, so we check 204. I'm going to come down below and divide 8 into 204. Now notice there's a remainder. So my answer here is no, because 8 does not divide the last 3 digits. That brings us to our test for 3 and our test for 9. Our test for 3 is a whole number is divisible by 3 if and only if the sum of the digits is divisible by 3. Our test for 9 is very similar. A whole number is divisible by 9 if and only if the sum of the digits is divisible by 9. So let's look at some examples. In part A, we have 1,002. My test for 3 and 9 involve looking at the sum of the digits. So 1 plus 0 plus 0 plus 2 is 3. Does 3 divide 3? Yes, and so 3 divides our number because 3 divides the sum of the digits. Does 9 divide 3? No. So 9 does not divide our number because 9 does not divide the sum of the digits. Let's look at another. We have 14,328. Again, my test for 3 and 9 is I look at the sum of the digits. So I add those digits together and I get a sum of 18. 1 plus 4 plus 3 plus 2 plus 8 gives me 18. Does 3 divide 18? Yes, and so 3 divides the number because 3 divides the sum of the digits. Does 9 divide 18? Yes, and so 9 divides the number because 9 divides the sum of the digits. Our last divisibility test are the test for 11 and 6. Now, the test for 11 is kind of complicated. We add every other digit. So you'll notice in your notes, it talks about the sum of the places in the even powers and the sum of the digits in the places of the odd powers. So we're looking at the every other digits. Then we take those two sums and we subtract them. Does 11 divide that difference? If the answer is yes, then 11 divides the number. If the answer is no, then 11 does not divide the number. For our test for 6, because 6 is 2 times 3, and 2 and 3 have no common factors, what we do is we look at 2, does 2 divide our number? And we look at 3, does 3 divide the number? If the answer to both of those questions is yes, then 6 also divides our number. So let's look at some examples. In part A, we have 18,124. Now first, we want to think about whether or not 6 divides our number. Our test for 6 is we look at 2 and 3. Now we choose 2 and 3 because 6 is 2 times 3. And notice 2 and 3 don't have any common factors. So let's start with 2. 2 divides our number because it's even. For 3, I look at the sum of the digits. Now when I add those digits together, I get 16. Now notice that 3 does not divide 16, and that tells me that 3 does not divide my number. Now for 6 to divide the number, my answer for 2 and 3 has to be yes for both of them. If either one of these is no, then my answer for 6 is no. So here my answer for 6 is no because 3 does not divide 18,124. Now let's look at our test for 11. For 11, I look at every other digit. So notice I've underlined every other digit in purple, and I added those digits together. 1 plus 1 plus 4 is 6. Then I'm going to look at the remaining digits. I'll underline those in blue. 8 plus 2 is 10. Then I'm going to take the difference of these two sums. So 10 minus 6 is 4. The question that I asked for 11, does 11 divide 4, this difference? The answer is no, and so 11 does not divide our number. On a show work question on your quiz, you would be expected to show something similar to what I've shown on the screen. Let's look at another example. So let's start with 6. We want to know, does 6 divide 185,112? Remember, our test for 6 is we look at both 2 and 3. Does 2 divide the number? Well, yes, it's even. Does 3 divide the number? Well, let's see. We add the digits. 1 plus 8 plus 5 plus 1 plus 1 plus 2 is 18. 3 divides the sum of the digits, and so our answer for 3 is yes. Because the answer for both 2 and 3 are yes, our answer for 6 is also yes. So 6 is yes because both 2 and 3 divide the number. Now let's look at 11. So with 11, we look at every other digit. So I'm going to underline every other digit in purple. So we have 1 plus 5 plus 1 is 7. Now the digits that are left, I'll underline in blue, and I'm going to add those digits together. 8 plus 1 plus 2 is 11. Then I take the difference of those two numbers. 11 minus 7 is 4. Does 11 divide 4? No, and so 11 does not divide our number. You're always looking for that test for 11. You take the sum of every other digit, so you'll have two sums. You subtract those two sums, and then you look at that third step. Does 11 divide the answer in the third step? That's your subtraction. If the answer is yes, then 11 divides the number. If the answer is no, then 11 does not divide the number. Let's look at one more with 6 and 11. For 6, I remember our test, do 2 and 3 divide our number? Well, 2, yes, it's even. The number is even. For 3, we add the digits together and we get 20. Well, 3 does not divide 20, so 3 does not divide the number. And because our answer for 3 is no, our answer for 6 is also no. Now let's look at 11. So we look at every other digit. So 2 plus 0 plus 8 is 10. Then we'll look at the digits that are left. 7 plus 3 is 10. 10 minus 10 is 0. Does 11 divide 0? The answer is yes. 11 divides 0, and so 11 divides our number. In our last example, we're going to put all these tests together in one big example. So we have one huge number here. 57,729,364,583. Part A, is this number divisible by 2? Well, no, because the number is not even. Part B, is the number divisible by 3? Well, if the number is divisible by 3, then the sum of the digits is divisible by 3. So I'm going to add all of those digits together. When I add all of those digits, I get 59. 3 does not divide 59, and so 3 does not divide our number. In a show work question, you would also need to show your work where you added the digits together to get 59, and then you would need to write your reason that 3 does not divide the sum of the digits. So part C, does 5 divide the number? Well, the answer is no, because the number does not end in 5 or 0. Part D, does 6 divide the number? Remember, for 6, we go back and we think about 2 and 3. 2 did not divide our number, so 6 does not divide the number. Part E, 8, we look at the last 3 digits. Well, the last 3 digits are 583. 8 is not going to divide 583, and so 8 does not divide our number because 8 does not divide the last 3 digits. For 9, we look at the sum of the digits. Remember from Part B, the sum of the digits was 59. Well, 9 does not divide the sum of the digits, and so 9 does not divide our number. Part G. For a number to be divisible by 10, the number has to end in 0. This one does not, and so the number is not divisible by 10. And we come to our test for 11 in Part H. For 11, we look at every other number. I'm going to put a purple line above every other number. And so when we add 5 plus 7 plus 9 plus 6 plus 5 plus 3, we get 35. Now the numbers that are left, I'm also going to add together. I'll put blue lines above those. When I add those numbers together, I get 24. Then I subtract these two sums. 35 minus 24 is 11. Does 11 divide 11? Yes, and so 11 divides our number.